Okay, so let's start the experiment. As per the starting, first of all, we have to rotate our generator at its rated speed, which is 1500 rpm. And to do so, we are using this DC shunt motor for the prime mover, which should also be rotated at the 1500 rpm. As both are mechanically coupled, as motor will rotate at 1500 rpm, generator will get its rated speed. Now, to rotate our start our DC shunt motor, we have supplied the DC shunt motor with its rated voltage approximately 220 volt. Now, here by the means of this analog meter, we can see that we are getting our 1500 rpm rated speed. So right now the motor is rotating at its rated speed. So as the generator is also getting the 1500 rpm, means its rated speed. As of now, right now we can see that the terminal voltage of the generator is very much less, which is approximately 40 volt, because we have connected a very huge resistance in series with the field winding of the generator. So first of all, our first step is to get the rated voltage of the generator, which is near to 220 volt. So by reducing this resistance connected in series with the field winding, we can generate or we can increase the voltage. So here I am reducing the resistance and we are increasing the voltage now. Our ultimate aim is to get the 220 voltage here. So as we can see that we are getting our 220 voltage. Before proceeding further, we are just verifying our speed, which has been 1500 rpm or not, which has been reduced somewhat. Let's put it back 1500. Let's put it back to 1500. Why I am concerning with the speed? Because once you are start to take readings, all the readings that must be taken at its rated speed, that's a constraint we have to follow. So you can see that it is 1500 rpm now. We can start to take readings now. Now what we are going to do, we are going to start to increase the load. Here, as far as these two ammeters are concerned, this particular ammeter is going to measure our field current, and this particular ammeter will measure our armature current, and here this particular voltmeter will measure our terminal voltage. Increase the current. So we are now increasing the load. As the load will increase, the speed is going to decrease somewhat. Before taking the readings of VL, IF and IA, we have to first of all put our speed back to 1500. How much speed is right now? Let's verify. It has been reduced somewhat. Okay, it is nearly 1500 now. Now we can take the readings. As of now, we can take the readings as this is our field current. Our field current is 0.5 ampere. This is our armature current is, this is our load current is. Our load current is 0.8 ampere. It is 0.8 ampere, and this is our terminal voltages. Our terminal voltage is 214 volts. This is our first reading.
Good.
So as we have measured the readings, IF is equals to 0.5 ampere. load current IL is equals to 0.8 ampere, and load terminal voltage is 214 ampere. Now armature current is also required to be measured. In our case, armature current will be the load current plus field current. So the summation of these two will give us the armature current, and this is our induced EMF. So VL is equals to IA plus IA, VL plus IA RA. So by means finding out the armature resistance RA, and multiplying it with the armature current and adding it with the load current, load voltage, we are going to get here the induced EMF voltage. So this is our load voltage, and this will, here we will get the induced EMF.
बोल.
Okay, so this is our readings that we have taken for the internal and external characteristics of the DC shunt generator.